Hi students, hope you are safe and happy at home. It's me, Arun Abraham, your class in charge. In our course, Object-Oriented Programming using C++, we have already covered 4 units. There are few more topics to cover in the last unit. Let's start with virtual functions. In the first unit, we have studied the concept of polymorphism. There are two types of polymorphism. They are compile-time polymorphism and runtime polymorphism. The compile-time polymorphism is achieved using two methods. They are function overloading and operator overloading. And the runtime polymorphism is achieved using virtual functions. Let us consider an example. We have created two classes using inheritance. There's a base class called base and a derived class called derived. The base class contains a data member called x and a member function called display. In the derived class, there's a data member called y and a member function called display. Both the classes, base class as well as derived class, have the same function name. Both have the function name display. Here also the function name is display. Coming to the main function, we are creating a base class object called b and a derived class object called d. In addition, there is a base class pointer called p, base star p, a base class pointer called p is created. Moving to the next statement, p is equal to ampersand b. Pointer p is assigned the address of base class object b. P is equal to ampersand b. We can say that p is pointing to base class object b. In the next step, display function is invoked. P arrow display. Since p is a pointer pointing to the base class object b, p arrow display function calling will invoke the base class display function. This function will be invoked. The value of x will be assigned to 5 and this message will be displayed to the output screen. X is 5. Moving to the next statement, p is equal to ampersand d. That is, the pointer p is pointing to the derived class object d. This is allowed in C++ because C++ supports the concept of polymorphism. That is, when the pointer is pointing to the base class members are to be accessed. And the same pointer is pointing to the derived class, then derived class members are to be accessed. But here when we call p arrow display, actually we want to invoke the derived class display function. But this will not happen. Instead, the base class display function is again invoked. This happens because of early binding. Early binding is an important topic. It is also known as compile-time polymorphism. Early binding is the process of associating or linking variables with functions at the time of compilation itself. While compiling the statements p arrow display in both the cases, compiler assumes that the display function to be invoked is base class display function. Here also the base class display function. This is because p is a pointer to the base class. Compiler only checks the type of pointer. it does not check the pointer points to which object. Since C++ supports polymorphism, the second function call should invoke the derived class display function. This is because in the previous step, P is pointing to the derived class object, and therefore it should be behaved differently in the changed situation. This can be achieved with the help of virtual functions. Early binding can be avoided with the help of virtual functions. Here, display function is declared as virtual. Therefore, pointer P is not linked with the base class display function. It will link functions with variables only at the time of execution or runtime. Therefore, this is called runtime polymorphism. In this example, P is pointing to the base class object B, and therefore this statement P_display will invoke the base class display function. But in the next statement, P is equal to &D. That means P is pointing to the derived class object. In the next statement, we are invoking the display function of derived class. Here, P_display will invoke the derived class display function. This is the advantage of virtual function. Since the binding is done at runtime, this is known as runtime polymorphism.